everyone, welcome to MA 1103 Business Mathematics, and today we will learn about part of chapter 1, which is functions. I'm Renovia Simayuntak, and we will start with the definition of a function. So what is a function? So you can see there that a function is a rule. So first of all, it's a rule that assigns objects in a set A to objects in a set B. Okay, but there is also properties of the assignment. Yeah, so the first one is each object in set A has to be assigned. So everything in A has to be assigned, right? And the second one is everything in set A will be assigned to exactly one object in set B. So we couldn't have one object in set A to be assigned to more than one object in a set B. So that's the definition of a function. So you can see there are two illustrations there. Yeah. The first one on the left, we have an illustration in the diagram. So probably you know it as a Venn diagram, yeah? So usually we use the term Venn diagram for this kind of diagram. So you can see here all the all the elements in the set A are assigned, yeah? And if you see each of the elements in the set A, they all are assigned. So this one is assigned to exactly one. This one also, and you can check the two others are also being assigned to exactly one object in set B. Okay, and probably we can also see function as a machine. Yeah, so in the right hand side you can see a machine which has input and output, and you can see for each of input you can only have one output. Yeah, so this is the kind of machine where you put in one input and you get exactly one output. So it cannot be stuck in the machine without an output, or it cannot give us two different outputs. Yeah, okay, so that's the illustration. And we also have the definition for the set A. Yeah? So usually the set A is called the domain of the function. Yeah, and the set B we call the range of a function. Okay, so that's the definition. So now by using that definition we can decide which one is a function and which one is not a function. Yeah, so let's see this Venn diagram. Is this one a function? Well, we can see here we have two sets, okay? And everything in the first set, or what we call set A, is being assigned. So, okay, so that's one property being checked. What is the second property? The second property that each of the elements in set A should be assigned to exactly one element in the set B. So if we see this element here, it is being assigned to two elements in set B, right? To this one and this one. So this kind of assignment does not fulfill one of the property in the definition of a function. So this is not a function, right? Okay. What about this one? Is it a function? So everything here is being assigned. Check. And you can see each of the elements in set A is being assigned to exactly one element in the set B, right? Okay, so this is a function. Let's see another example. Is this a function? Yeah, we can clearly see that this is not a function. Why is that? Because not everything inside in set A is being assigned. So this is not a function. Okay. So we know what a function is. Now we want to know how we can represent a function. Yeah. So in this subchapter we will learn two ways of representing a function. First one is by using an equation. Yeah. So we usually use this notation. Y equal to fx. So f is the name of a function. X is the elements of the domain, and Y is the elements of the range. Yeah, so this is how we write a function in terms of equation. So here, X and Y are called variables. Yeah, X is independent variable because it's the element of the domain. Yeah, and Y is the dependent variable. Why is it the dependent variable? Because the value of Y is dependent on the value of X. Okay, so this is one example. So if we have Y equal to fx equal to x squared plus 4, then of course we can decide what is the value of Y when x is equal to 1, for example, or x is equal to -1, or x equal to 0, or whatever value of x in the domain. Yeah. Okay, so this is one example. And here, because x and y are just denoting the variables, then we can substitute them with other letters. Yeah. So for example, we can use t instead of x, and we can use s instead of y, but both of these representation or both of these equations are representing the same function. Okay. Now we will move to the second way to represent a function, which is by using a tabular data. So this is data that I took from the Bank of Indonesia website. It's about the exchange rates on transaction of US dollar to Indonesian rupiah. So here we have the date, yeah, the date that we will use as the domain. Yeah. Okay, but then we have here two values for each date. Yeah, we have cell values and we have by values. Then you can say, well, it is not a function. Yeah, for each date we have two values, so it is not a function. Yeah, that's correct. But we can define actually two functions now. Yeah, so now for each of the date, yeah, we can have the by function. So for instance, for 18 September we have this value 14694. That's just for the by, so we can define that one function. And we can define another function, which is the self function. And for 18 September, we have a different value here. Okay, so now we can, based on this tabular data, we can define two different functions. Yeah, the first one is function F, which is the sell exchange rate from US dollar to Indonesian rupiah at the end day after 13 September. Yeah, so we see again the tabular data. It starts at 14 September. So this is the beginning. So end date after 13 September means that 14 September is the first day, yeah, after 13 September, 15 September, second day, and so on. Yeah. So we can have this first function, and then we have also the second function, which we can call Gn, yeah, or you can use any other name for the function. Okay, so here we have n is the independent variables, so all the values in the domain, and we can see f1 is equal to this one, and so on. Yeah, you can match all these all these values of a function with the tabular data that we have before, and we also have the second function. And of course, in here we have the domain of f and g is the set of 1, 2, 3, 4, 5. Yeah, because we only have 5 values in the tabular data. Okay, so this is how we rewrite tabular data to equation. Yeah, so these two representations can be exchanged to each other. Yeah, if we have tabular data, we can rewrite the function in equation, or maybe the other way around. Yeah. Okay. So the next thing that we will learn about the function is what we call the natural domain. So in the definition of the function, you have learned that the set A, yeah, the set where the elements are being assigned is called the domain. But we can have natural domain for each function, yeah, even though we are not told what is the domain of the function, but we can decide what is the natural domain of a function. So what is the natural domain of function? It is the set of all real numbers for which fx is defined. Yeah. So we have to find all x where fx is defined. Yeah. So there are two situations that you need to be considered. Yeah. The first one is that we cannot have division by 0. Yeah. It is undefined if we have a division by 0. And then we also could not have even root of a negative number. Yeah, it is undefined in the set of real numbers. Yeah, of course, if we consider other set, yeah, not real numbers, it may be possible to have even root of negative number, but not in the set of real numbers. Okay, so again, there should not be divisions by 0. There should not be even root of a negative number. Okay, let's see an example. So the first example is this function, and you can see that there is a division in this function. So of course we cannot have division by 0. So we have 1 minus x squared should not be equal to 0. And we can factorize this 1 minus x times 1 plus x should not be equal to 0. Okay, So x should not be equal to 1. N, right? It's n, not r. Why? Because if we have two numbers being multiplicated and the result is not supposed to be 0, of course, both of them should not be 0. Because if one of them is 0, of course, the multiplication will be 0. Okay, so this is n, x not equal to -1. Okay, so we have here the natural domain of f, or sometimes we use this notation, the f should be equal to what? The set of real number. So this is the notation that we use for the set of real number, but not all of them. We have to take out -1 and 1. Yeah, so this is how you write the domain, the natural domain, sorry. Remember, natural domain is a set, so you have to write it in terms of set also. Example, so here we have an even root, right? And we know from before that we cannot have negative number inside an even root. So here we have u plus 2 should be greater or equal than 0. Yeah, and of course u is greater or equal than -2. Okay, so how do we write the domain? So we have here the natural domain of the function g, or we can write it as dg here, is equal to the set of u where u is greater or equal than -2. Yeah, so remember, the natural domain is a set, so you have to write it in terms of a set. Yeah, so other way to write this is in terms of range. Yeah, so for instance, if we have something like this, x is greater of or less than, say, values a and b, so x is between a and b, we can write it in the term of range like this one. Yeah, or if it is included the endpoints, yeah, so less than equal, greater than equal, then we can write it as this one. Yeah, what about if we only have x greater than a? Yeah, so okay, so we have from a, but because it's greater than a, then it is up to infinity. Yeah, so we can write it like that. And the other one is if we have x less than or equal than a, we have here a, yeah, from what up to a, so from minus infinity up to a. Yeah, so we can write it in this way. Yeah, okay, so if we have something like this, how do you write it? Okay, so it's included -2 up to infinity. Yeah, so here is range notation, which you can use also to write the natural domain of a function. Example, this one. So again, we have a division, and we have x minus 1 should not be equal to 0. Or here we have x is not equal to 1. What about this one? This one is an odd root, yeah? So we don't have anything, we don't have any properties for odd root. So only this one. So x is not equal to 1. So the domain of g, so the domain of h actually, is equal to all the real number minus the number 1. Okay, so that's the natural domain of a function. And the next one is what we call piecewise defined function. So it is possible to have more than just one formula for a function. Yeah. So here we have an example of a function which has two different formulas. Yeah. 1 over x minus 1 and then another one, this one. Yeah. But of course, because we have the property of a function that it can only have one assignment for each object in the domain. Of course, the set where each formula is defined has to be different. Yeah. So for this one is x less than 1, and here x is greater or equal than 1. So there should not be the same values in each of the subsets. Yeah. All right. So here is an example of a piecewise defined function. Yeah. Where the formula describes the function in a subset of the domain. So here is just an example of two formulas, a function with two formulas, but of course we can have a function with more than two formulas. Okay, so what is f of minus half? So we see that minus half is located in the subset, and of course we use the first formula to define the value of minus half. So we have f of minus half will be equal to, what is that? 1 over minus half minus 1. So we have here 1 over minus 3 over 2, and this is equal to minus 2 over 3. What about f of 1? F of 1, of course, 1 is located in the subset, and you have to use the second formula. And it is the same also for 2. Yeah, 2 is located in the subset, and you have to use the second formula. Okay, you can do it by yourself and count what is f1 and f2. And now we will move to another concept of functions, which is what we call the composition of functions. So if we have two functions, we can combine them together. Yeah. How to combine it? We can combine it in many different ways. One of ways is what we call composition of a function, of two functions, which we write as f of gx. So from the notation, you can see how we combine these two functions. Yeah, it's just by substituting g into the function x, into the function f. All right. So let's see one example. So if we have f is u to the power of 3 plus 1 and g is x plus 1, then if we compose f and g, yeah, f gx, then it means we substitute the function g into function f. So what we have here, f of gx is equal to, we substitute u here with the function g. So we have here x plus 1 to the power of 3 plus 1. It is equal to, yeah, you can try to simplify this function. Yeah. Okay. What about g of x? Yeah. So now we substitute f into g. And you say, but this is fx, but here is fu. Remember what we discussed in the beginning? It doesn't matter what the letter is, yeah? It's just representing a variable. Okay, so now we have here g of fx. This one should be equal to, we substitute f into g. So what is it? So x here, substitute into that one. So we have x to the power of 3, but now we have to use x, yeah, because this is fx, not u. Plus 1, and then plus 1. Yeah, and then this is equal to x to the power of 3 plus 2. Okay, so is it the same with the one before? No, it doesn't, yeah. It's not the same. Okay, so that's usually happen in general, that f gx and gfx are not the same function. Okay, so that's composition of functions. And then now we want to learn 3 important functions in economics. The first one is the demand function. The second one is the total revenue function. And then the last one is the total cost function. Yeah. So here we have a demand function. So what is this function? This function is a function that relates the unit price P. So we have price P with the number of units demanded at that price. Yeah. So usually if the price getting high, then the demand will be getting low, right? Yeah. That's the usual way, but sometimes it differ. Yeah. Okay, so that's the demand function. And then we also have a total revenue function, which is what? Which is just the number of items sold times the price. Yeah, so it is x times p, or x times dx. Yeah, it makes sense, right? How do you count your revenue? Just by multiplying the number of items being sold or being demanded times the price. Okay, so now the last function is total cost, and it is called it is usually donated by Cx. And then from the total cost we have the fourth function, which is the profit function. And how we count the profit is just by subtracting costs from the revenue. Yeah, so we have this one, x dx minus x. Okay, so actually it is not 3, but 4 important function is economics, demand, total revenue, total cost, and profit. Okay, so this is an example. Yeah, you can read the example here. And what we have here? We have the demand function. Oops, sorry. We have the demand function. And we have also the cost function. Yeah, so this cost is in $1,000 and the price is in dollars. Okay. So now what are the revenue and profit functions? So the revenue. So do you remember what is the revenue? Revenue is the number of items being sold times the price. Yeah. So we have x times what is the price minus 0.7x plus 51, or we can rewrite it as minus 0.27 x squared plus 51x. Okay, so what is the profit? Profit, remember, how do you get profit? By subtracting the cost from revenue. Okay, so we have here minus 0.4 minus the cost. Yeah. So this is going to be what? Minus minus. So this is minus 2.5 x squared plus 51 minus 3.5 and then minus 85. Okay, so this is the profit function. Okay, we can also being asked this one, yeah. For what values of x is the production of the coffee makers profitable? Yeah, what does it mean profitable? Profitable, of course, the profit should be something, yeah. It should be something positive, I mean. Yeah. If it is 0, there is no profit. If it's negative, then it is a loss instead of a profit. So here we have profit should be greater or equal. Is it greater or equal? No, it is not greater than equal. Yeah, because equal 0 means there is no profit. So we have profit greater than 0. Yeah, and then from before we have this value, this function, sorry. So I can rewrite it minus 2.5x squared plus 47x minus 85 should be greater than 0. Okay, do you know how to solve this kind of inequality? Okay, yeah, you can try to think of it. Yeah, this is what you have learned in high school. Okay, try to solve this. Yeah, and then you will get the value of x where this profit function is greater than 0. Yeah, okay, try to think and try to solve. What we learned? We have learned about function. We have learned about how to represent a function in two ways, by equation and by tabular data. We have learned about the natural domain of a function. We have learned about composition of function. And we also have learned about 4 important functions in economics. Okay, so that's it for subchapter 1.1, and I'll see you in another video. Good day.